Hello, everyone. My name is Xuefeng Liu. I come from ZTE Corporation, and I'm an OpenStack Signing project developer.
Hello, I'm Nicolas Planel from Red Hat. I'm the principal software engineer. And today we plan to present you the VMContainer centered networks, fault auto-healing, and visual practice.
So the agenda is why we do this because virtual network is complex, and so we will review neutral virtual network first, and next we will give a solution for this. First, let's see the availability in the OpenStack. There are 4 factors availability in the OpenStack. One is for the OpenStack service, and for the host node, physical network, physical storage, and the other is VM availability. The last one is application availability. Both of these can be monitored easily, but for the virtual network, it's hard. So we do this work. Next, we will review the neutral virtual network. So we can see there are many devices in the virtual network. First is the type device, a virtual network kernel driver. It can generate Ethernet driver. It can be seen by IP link commands, and it can attach to the user space programs. For example, it can attach to a user space VM network interface. And next is VETH pair. There are 2 virtual network interface connect via a virtual wire. It used to connect mutual virtual networking components. For example, it can connect network namespace. Next is Linux bridge. It's a virtual switch. In OpenStack, we named it QBR. And the tab and the QVB are all in the QBR. It's a layer 2 switch. And next is OpenWe switch. It's a more complicated visual switch than the Linux bridge. Visual and it can connect visual and physical interface. You can see it in the OS database. It's also a level 2 switch. It supports open flows. And in OpenStack, we will use it as brint, brtwin, brex. They can be powered by OS. So the last one is network namespace. It's an isolated network stack. Interface can be aligned to network namespace, and it split routing tables. 2 interfaces aligned to 2 different namespaces can have the same IPs. Neutral use network namespace to implement DSP agent and LSN agent. So what's neutral to do? Neutral has some components. Neutral service, it allows users to create network subnets and routers, provide the APIs, and manage the database. LSN agent routers, it supports routers, LSN traffics, provide floating IPs, ML2 agent. It supports switch L2 traffics. Also, it has DHCP agent and metadata agent. And what's the traffic in the neutral? Neutral supports instance to instance with the same network. Instance live can be in the same host and in the different host. The traffic can be also can be in the different networks. Instance to the DHCP, instance to the public network. Also, the traffic can be user to the instance. It can be provided by floating IPs. But all these things is neutral support, and so if we troubleshoot the problems, it's hard. Let's see an example for visual network faulting analysis by hands. It's really painful. So we may should to do run commands such as Nova list, Nova show, Nova interface list, and then we found the host node. We use SSH. Then we use visual list, find some libvirt status, and find some obvious shoe, some port status. Then we send this information to the experts to do some analysis. Okay.
So for viewing the virtual network, I will introduce the Skydive project that we started 2 years ago. The major key points are like the SDN agnostic solution. We have supported like the Docker, some Kubernetes, and even open contrails. It's based on probes like topology probes and flow probes. We not go deeply today, but basically that's how that works. There are some agents, and they will put the data to an analyzer, and they can store in the database. The Skydive is non-intrusive and easy to deploy. It's just a single binaries. The topology and the flow are based on a graph engine that we have embedded Skydive. You can query the graph via CLI or via an API. The database storage is used if you want to do post-mortem analysis. So I mean, at 4 a.m. you have some issues, the port didn't show up. We didn't know, the customer just say, oh, you have a problem with the VM at this, but nothing exists anymore. So you can go back in time and know what exactly was the topology and what the flow passed through. We have multiple API on the Skydive, like to capture packet, to inject packets. For the topology, some alerting on the flow, based on the flow, or based on the topology. For example, if one of the ports has the NTU less than 1,500, can put an alarm for that, thanks to Auto. The URI of the Skydive networks and the GitHub project page. So why we write the Skydive is basically to do troubleshooting. So where are the packets are dropped, where the packets are fragmented, where are the congestion points on the networks. These are all the kind of questions that everybody maybe used to face once, and never is not so easy to troubleshoot. So what's the packets of the path of the packets that we don't know if something is set up correctly or not correctly? If the path is broken in OVS or before, or the VM didn't set up the port correctly, etc., etc. There are many use cases. It could be more as well as the congestion, the number of flows that you can see on the link. It could be the number of TCP session, or maybe related to a tenant. All this information are stored and centralized in Skydive. So basically here is a simple demonstration, an overview of Skydive. You can go on the website, you will see the same demonstration. It's a full physical nodes with some VM, where we start to add some capture between two nodes on the networks, like on the bridge. And afterwards, we inject some packets from one VM to another one. So you show it from one VM, second VM. And that's the capture, sorry, I go too fast. And here, that's the first node for the capture, the second node for the capture. So it's the injection, and we inject some ICMP packets. As you can see at the bottom, it's a little bit fast, but you will see that they have ICMP v4 packets, and you will just receive it online. And the demo go so on. So basically, here you can see some metadata of the port. If you select one of the ports, on the right you have the name, the TID, and the type of port. The other views are you can see the path of the connection between the VTH, the QBR, the QVB, all the bare int, and etc., all the bridge and the ports of OpenStack. And this, in this case, we can see some metadata with the tenant ID attached with the neutron IP on this port. And we saw as well some flow, typically IRP Ethernet for this one. So all this is like we get a lot of data, and we can have a feature like a remote auto check feature from a ZTE. By viewing the visual networks is a small part of the solution that we just saw what the topology or how everything is connected or not. So, and we can add some some support with the API of Skydive, like for the capturing, generate packets, etc. And this indicator can make a new rules to analyze and troubleshoot the issues automatically. So the idea behind that is like we can check first the physical networks in good health, thanks to consult.io. And we also check the configuration, like the services are up and running correctly. If, as usual, should works all the time. And then we can specify some rules on the QVO and tap on the rootkit of the packets. If no packets pass through, we can suspect like the OVS problem or VLAN or problem of tagging. Afterwards, it could be like if you see more packets in one way, and we can receive the security groups, or maybe the problem in the VM. So the idea is to consult generate a script that query the Skydive via Gremlin queries. Gremlin queries is just a way to query the topology. And we can look at the number of packets received and sent on one port, from the statistic of the port. And with the script for each port, it will be running and give you the clue of what the suspected troubleshooting issue happens. So, auto-reading.
So after we do auto checking and by some RCF root case analysis, we can do auto hearing. Because Sunling can do the VM management, so we can do auto hearing by Sunling project. Sunling can Sunling is a cluster management project in the OpenStack. You can develop your nodes and containers by Sunling. And after you develop this one, you can do listening and polling of the health check. Also, you can do cluster management, and you can receive the monitor from the webhook or the messenger. And because of this, you can do auto hearing using Sunling project. How to do failing detecting by Sunling? The detecting type of Sunling has node status polling and VM lifecycle events. Also, it can receive the monitor from the Cilimeter, Zabbix, also the visual network auto checking result. This result is we came from the skydive. This one is about how to develop nodes from Sunling. And about monitor, we will do auto hearing. We can do the recover actions from the messenger and the webhook. So the recover action can be rebuild, reboot, and migrate. Also, some Ansible share. So we can support a framework to do the auto hearing and we can integrate skydive and some other monitors to do the whole work. Okay. Next, here is the future work. About network, we will do some, here is follow analysis and some new features. And about auto-healing, we will mix more monitors to do auto-healing and integrate with RCA software. Thank you.
Thank you, everyone. If you have any questions. Some question?